So today we are looking at applications of law of cosine. This is the second day for section 5.6. Our first example says a tunnel is to be built through a mountain. To determine the approximate length of the tunnel, an ambitious math student with a homemade transit takes two measurements from a fixed point as shown in the figure. Use the student's data to determine the length of the tunnel. So if you look at what we're given, we've measured the angle in between the two sides as 82.4 degrees, and we have two side lengths of 388 feet and 212 feet. If we're trying to find the length of the tunnel, based on our picture here, this would be side C. So we want to use law of cosines, since we have side angle side, which says C squared equals A squared plus B squared minus 2AB times the cosine of C. So plugging in our numbers, we have C squared equals, and A would be 212 squared, plus B squared would be 388 squared, minus 2 times the product of those two, times the cosine of our given angle, which was 82.4 degrees. And then to find C, we would have to square root that. So go ahead and use your calculators, type that whole thing into your calculator. We should end up with C being 416.81 feet. Our second example says an airplane pilot sets out from the airport on a heading of 20 degrees, flying at 200 miles per hour. After an hour, he changes his heading to 40 degrees. After another half hour on this new heading, he lands at his house. What is his distance from the airport to home? And then in the morning, when he leaves his house in his plane to return to the airport, on what heading should he fly to get there directly? So I want you to take a minute, pause the video, and see if you can sketch a picture that would go with this situation. All right, let's check our picture. Let's say we start here from point A. We'll call that the airport. And it says we are on a heading of 20 degrees. That means from straight vertical, all right, from due north, we have turned and gone 20 degrees clockwise. So we're at an angle here where this is 20 degrees. Okay? And it says that we go on that path for an hour, and we are going at 200 miles per hour, which means the length of that segment of our trip would be 200 miles. Okay? After an hour, we change direction. So again, from vertical, we are now heading at an angle of 40 degrees. Okay? Now we only travel in that direction for a half an hour, and if we're going 200 miles per hour, in a half an hour we would have covered 100 miles. So the length of this segment would be 100. And at that point we land at our house. Okay? And the question is, when we return to the airport the next day, what would be the distance that we travel if we went directly there? And then also what bearing or what heading should we use to get there? So looking at our triangle, we have two sides. We do not know the included angle. I'm going to call this point B. But we can find angle B, all right? Because we know a couple things about the angles around angle B. So I'm just going to sketch a side picture here. All right, so here's my angle B. And we were told that this is 20 degrees, which means this is also 20 degrees. Because those are alternate interior angles, our two vertical lines would be parallel. We also know that this is 40 degrees, and this makes a straight line. So the angle under here would have to be 140 degrees, which makes this full angle here 160 degrees. Okay, so we have a side angle side situation here where we have one side that's 200, an angle that is 160, and then another side that's 100. Okay, so we can find this length that would be called B in this situation since I labeled that angle B. And we're going to use our law of cosines again since we have side angle side. So B squared would equal the two sides squared, so 200 squared plus 100 squared minus 2 times the product of the two sides and the cosine of our 160 degree angle. So to get B, we would have to square root that. Grab your calculators and go ahead and type that in. And we end up with B, the total distance that we are from the airport to the house is 295.952 miles. Okay, so we've answered the first question, just how far is he going to have to travel? All right, what is the distance from the airport to his house? So we have that finished. The second question says, in the morning when he leaves his house in his plane to return to the airport, on what heading should he fly to get there directly? All right, so take a minute, think about if we had a vertical line here, okay, we are looking for the heading from straight north turning clockwise. So the angle we really want to find now would be from here all the way to my red segment there. All right, so we know the vertical part, this much of it from here to here would be 180 since it's a straight line, but we are going to have to find that little piece between the green vertical line and the red segment. So we are going to find angle C. We'll label this one C. All right, and then we'll use that to help us figure out this angle. All right, so angle C. We can use a law of sines on this part. We have the sine of angle C equals, sine of C is to the opposite side, which was 200, as the sine of 160 is to the side opposite 160, which we just found to be 295.952. All right, so C is going to be inverse sine. We have to multiply the 200 over, so we have 200 sine 160 divided by 295.952. All right, so grab calculators. Let's find angle C. All right, check your answer. You should have 13.364 degrees. All right, so what we just found, and our picture's getting a little messy here, but what we just found is this section right in here, okay? That is 13.364 degrees. We know, based on our 40-degree angle here, let me get a different color here. We know that if this is 40 degrees here, we also have 40 degrees here. But we've used up, where I have the little black mark, we've used up 13.364 degrees of that. So this part here, this remaining part, would be 40 minus that. All right, so 40 degrees minus the 13.364 degrees gives us 26.636 degrees. And then going back, we said the angle that we're looking for is this whole thing. So we need 180 plus what we just found, the purple angle. That was 26 degrees. So our heading from the house back to the airport needs to be 180 degrees plus the extra 26.636 degrees, which gives us a total of 206.636 degrees. All right, our third example. It says the bases on a baseball diamond are 90 feet apart and the front edge of the pitcher's rubber is 60.5 feet from the back corner of home plate. All right, so take a look at our picture. We are told the distance here from home plate to first base is 90 feet and from home plate to where the pitcher is 60.5 feet. It says to find the distance from the center of the front edge of the pitcher's rubber to the far corner of first base, which means we're looking for this section C here. Notice that they've given us a 45-degree angle. We have a diamond here where we've split 90 degrees here in half. We're given 45 degrees for that smaller piece. All right, so if we want to find side C, we know an opposite angle and the two sides around it. We can use law of cosines. So C squared is going to be the two sides squared, so 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times the cosine of 45. All right, square rooting that final answer. We should end up with a total distance of 63.717 feet. All right, we have one more example to look at. It's an exploration question. It says we're going to be estimating the acreage of a plot of land. It says Jim and Barbara are house hunting and need to estimate the size of an irregular adjacent lot that is described by the owners as a little more than an acre. With Barbara stationed at a corner of the plot, Jim starts at another corner and walks a straight line towards her, counting his paces. Then they shift corners and Jim paces again until they have recorded the dimensions of the lot in paces as shown in our figure. They later measure Jim's pace to be 2.2 feet. So they're asking us to find the approximate acreage of the lot. All right, so we're going to walk through our steps here. Notice the picture at the bottom, all right, where the paces have been listed out. It says use Heron's formula to find the area in square paces. So we have two separate triangles. We're going to have to find each one individually. All right, so step one. We need the semi-perimeter. We'll start with this. I'll call this 1 and this section 2. So the semi-perimeter for 1 is going to be 81 plus 115 plus 112 divided by 2, and that ends up being 154. For section 2, the semi-perimeter is 86 plus 102 plus 112 divided by 2, and that ends up being 150. All right, so we have the two semi-perimeters. The area then for section 1 is the square root of 154, the semi-perimeter, and then we need to subtract each side from that semi-perimeter. So 154 minus 81, 154 minus 115, and 154 minus 112. Go ahead and type that in your calculator. while I set up the second one here. All right, our first one we should have 4,291.199, and our second area is 4,184.543. So total area, if we add those two together, gives us 8,475.743. Now that is in square paces. Okay. Then part 2 says to convert the area to square feet using the measurement of Jim's pace, which was 2.2 feet. All right, so for part 2, we have 8,475.743 square paces. We're going to multiply by a conversion, and we are told that each pace is equivalent to 2.2 feet. But since we have paces squared, we need to square this. All right, so use your calculators. You're going to take 8,475.743 times 2.2 squared. So we end up with the area being 41.22.595 square feet. Okay, part 3 then says there are 5,280 feet in a mile, so convert that into square miles. Okay. All right, so part 3, we have 41,022.595 square feet, and we want to convert it into square miles, and we know that 1 mile is equivalent to 5,280 feet. Again, since we want to cancel feet squared, we have to square that quantity. We end up with 0.00147 square miles. Question 4 says there are 640, it says square acres, but acre, we don't refer to that as square acres. 640 acres in a square mile, so we're going to convert this to acres now. All right, so 0.00147 square miles. Our conversion was 640 acres per square mile. All right, so take that decimal times 640, and we end up with 0.942 acres. Part 5, it says, is there good reason to doubt the owner's estimate of the acreage of the lot? If we go back to the original problem, it says they said it's a little more than an acre. We're actually getting a little less than an acre, 0.94, but since we have measured it off just by pacing it out, it's probably pretty close. I would not doubt the owners. So estimate is fairly close. All right, and then the last question said, would Jim and Barbara be able to modify their system to estimate the area of an irregular lot that had 5 straight sides? And you could basically do the same kind of thing that we've been doing. All right, we've got 5 sides. We could just form 3 triangles. And we could pace off each of those segments and then calculate it the same way. So yes, just make 3 triangles. Okay, so our assignment for the second day is listed here. Go ahead and try those.